Hello, everyone. Welcome here. Thanks for joining us today, wherever you might be tuning in from. Let us know in the chat panel where you're joining from. We have a big panel here today. I'm not sure, is everyone based in Vancouver? I think we have some folks from different areas of Canada.
I'm in Toronto.
I think almost everyone else is the Lower Mainland area.
Yeah.
Yeah, with the exception of Natalie. I think she's up in Ottawa.
Great, very cool. All right, well, without further ado, it is that time, so I'll go ahead and kick us off here. Welcome, everyone, to Safer's Tips and Tricks to Optimize 9 Favorite FME Transformers. We have a huge crew of panelists here today, all FME support specialists. You'll be hearing from 8 different experts today. And before we get started, I will take us all through some tips to using the webinar platform Livestorm if this is your first time in here. If you do have any audio issues at all, you can click that help button on the bottom left for 4 simple troubleshooting steps. Share your reactions with us throughout the webinar. We love to see them. There's a little react button on the bottom middle. And then we have the questions tab and chat tab. So in the questions tab, you can ask any questions you might have throughout the presentation. And then with the chat tab, you can leave any comments as well. I see you're all already using that, so that's awesome. All right, and so before we go through these tips and tricks, we'd love to know in the chat panel, what is your favorite transformer at this point in time? Should be interesting to see the different answers here. Maybe that'll change by the end of this webinar today. All right, and while you're still chatting that in, we will carry on here and go over our agenda. So you'll be hearing from 8 different presenters today on actually 9 different transformers, because we do have a 2-in-1 special from Trent coming up here. This is probably a very unique opportunity where you'll hear from 8 different experts. I don't know if we'll ever see that again in a webinar, so leave any questions that you might have throughout in that questions tab. To follow our 8 different presentations here, we'll be sharing out any resources on those different transformers, and we'll have live Q&A at the end. So any questions that we don't get to throughout or we want to elaborate on more, we will have time at the end for that as well. And without further ado, I will hand things over to Natalie to talk about the Creator Transformer.
Thanks, Elizabeth, and welcome everyone. I'm going to walk you through a bit about the Creator Transformer and demonstrate a couple of ways the Creator can give some added runtime control to your workspaces. First, a little intro to this versatile transformer. The Creator can create a variety of objects which may or may not have geometry. The choice is yours. I like to think of the Creator as that certain something needed to initiate a workflow. So if you need a point, you can just create a point. If you need something to carry attributes, you can create a null geometry object and work with that instead. The Creator is also quite unique among FME transformers, as it does not have an input port. This means you can place the Creator anywhere in a workspace that it's needed, and it won't depend on the actions around it to function as expected. I find myself using the Creator to initiate other transformers, some of which you see in the screenshot at right. I often pair the Creator with the FeatureReader, for example, and in this way I can read data sources into my translation at the exact point they're needed, rather than having to carry data sets through my translation from the start. I also use the Creator to construct mock data sets for testing upstream processes before bringing in my full data set of interest. This is useful where creating a sample of a source data set would be maybe time-consuming or even not possible. Just use the Creator to make something resembling your source data, and you can work with that instead. So now I'll demonstrate how you can really up the Creator's game by making use of some user parameters. First, I'd like to briefly highlight one of the Creator's parameters. So here I've accessed the Creator's parameters dialog, and you can see there are a few options available. But the one I'd like to focus on right now is this geometry object parameter, which is activated when you select geometry object as your geometry source within the creator. So selecting the ellipses next to this geometry object parameter will bring up a list of several predefined geometry objects to choose from and an interface to further define each object. Here you also have access to the XML definition of each of these objects. So if you are XML savvy, you can get into this definition and customize it with some attribution. Now, defining an object from within the creator itself is one thing. However, it would be even better if you could define that object at runtime. Luckily, FME has a geometry user parameter to accomplish this exact task. So here in the second bookmark, I've created a simple workflow to calculate the angle and azimuth of a line defined at runtime. Again, the geometry user parameter is going to come in handy here. And I've actually applied a geometry user parameter to the geometry object parameter of the creator. So if we go and have a look at this parameter under Manage User Parameters, and then I'm going to get into the geometry configuration of this geometry user parameter. And you can see that the interface looks exactly like the geometry object option within the creator transformer itself. So you can pick the exact same geometry objects from within a user parameter. So I'll just cancel out of this. And if I click Run on this creator, you'll notice that I'm prompted to define my input line right at runtime. So that's how you can use the geometry user parameter with the creator to define objects at runtime. Now, of course, you can add even more runtime control by applying more user parameters to your creator. In this workflow here, I've applied several user parameters to my creator, as you can see, which allows a user to create a well-defined bounding box at runtime. And then you can feed the bounding box into something like a feature reader to limit your read-in results to an area of interest. So if I click Run on this creator, you can see that I have a lot of choice in how I define my bounding box. So I can simply pick the 2D min-max option, or I can change over to a geometry object and define a polygon instead. This really gives a user lots of flexibility in defining a bounding box, and this will also allow for repeated runs should results for several areas of interest be needed. So those were just a couple of ways the creator can give some added runtime control to your workspaces. So here are some final takeaways for the creator transformer. Get creative with it. It's a pretty versatile transformer and can be readily customized. Don't forget about the creator's ability to add some runtime control to your workspaces through the use of that geometry user parameter that I showed you. And try playing around with the XML definitions of each geometry object to gain some added object attribution ability. Overall, though, use the creator anytime you need a sample dataset to do some testing, or if you need to initiate another transformer, particularly mid-translation. And with that, I'll hand things over to Dan.
Great, thanks Natalie. My name's Dan Minnie, and I'll be going over the FeatureReader today. FeatureReader in itself might just look like a regular reader, but it really allows for much more flexible and dynamic workflows. So it acts just like a regular reader. All the same formats are supported, but we can now use information and attributes obtained earlier in our workflow to perform advanced reading. So one of the main advantages in this is that we can actually do some advanced filtering before our data is even read in. And what this does is it puts the workload on the database to do all of that work, all of that spatial and non-spatial filtering. So, we can filter out our data to only the features we want, whether that's spatial or non-spatial. And that will really save us a lot of time and processing power. As you can imagine, if we were reading in, say millions of features and we want to narrow that down to just a specific where clause or maybe a bounding box around our city limits, then that can save us a lot of time and resources there. We've also got a sibling transformer called the FeatureReader, which I won't be going into detail today, but it is quite similar to the FeatureReader. And if you find this interesting, you might also want to look into the FeatureReader. So let's take a look at the FeatureReader in action. So I'm just going to share my screen here. And the first demonstration I'm going to be going over here is just a quick spatial intersect. So in this, we have our postcode boundaries. These are just postal code boundaries in the city of Vancouver. And I'll just show that quickly so you can get an idea of what we're going to be working with. And I'll view our data set. And once that loads, you'll see that we have our postcode boundaries in the city of Vancouver. So what we want to do here is we only want to be reading in features that land within these polygons. And to do so, we're going to be using the FeatureReader transformer. So with the FeatureReader, we've specified our format and our data set that we want to read in. We've chosen the parks layer. And the most important thing here is that we've set a spatial filter. So with our spatial filter, we can set up, tons of different filters. In this case, we're just going to be doing that initiator intersects result. And the initiator in this case is going to be that postcode boundaries since it's connected to that initiator port. We'll run the transformer. And you'll see when the transformer reads in those features, it's only going to be reading in the features that fall within the postcode boundaries. So as you can see, all of those points there are our parks, and we've only read in the ones that land within our postcode boundaries. So that's just a quick spatial filtering example. The same could be done if you're using the where clause. It would also save a lot of time and processing power in that sense. Next, looking at using a transformer to get a token, and then how can we feed this into our feature reader? So this could look like something like the ArcGIS Online token getter, or we could be using an HTTP caller to access a web service to grab a token. So I'll run our ArcGIS Online token getter, and this will grab a token from our ArcGIS Online account. So now that we've got the token generated, in our feature reader, we're going to be reading in an ArcGIS server feature service. We've specified that we're going to be reading in a bike paths dataset. And really what we're looking at here is we want to provide a token as our authentication type. And instead of manually inputting a token every time we run this workspace, we can actually just feed it the token that's coming from our ArcGIS Online token getter. So this is a really handy tool that allows any user to come to this workspace, grab that token, and run it whenever they want. Every time the workspace is run, it'll reset that token and grab a new one, so you're never going to have problems with your token timing out or expiring. So as you can see, we've read in that data set, and everything looks good. So those are just two quick examples with our feature reader. And I'm going to go back to our presentation here. And I'll hand it off to Trent.
Thank you, Dan. I'm going to jump in with the attribute remover or the attribute keeper. So I get to do a 2-in-1. Now, the attribute remover is, as the name suggests, it's primarily used for removing of attributes or lists from an input feature. And then, the inverse of that with the attribute keeper is that it's primarily used to keep attributes, including lists from an input feature. Now, the attribute keeper has an additional piece of functionality that I'll touch on in a demo later, where it allows the creation of bulk features, which can just improve performance downstream. So here I have a workspace, and what I'm doing here is I'm just reading in a CSV file that just has some health data in it. Primarily, all we're focused on, the data doesn't really matter too much, apart from that it's got a decent number of attributes. I wouldn't say it's got a lot, but it's got a decent number. Now, the first tip I'll have with the attribute keeper or the attribute remover is that sometimes you want to use the opposite transformer than what you are actually trying to accomplish within your workflow. For example, if you wanted to keep attributes, sometimes the attribute remover might actually be a quicker solution and just a nicer user experience to maintain, in terms of you can essentially do the same functionality that the attribute keeper or the attribute remover performs, but you have to select less. Basically, it requires less clicks, for example. So in this case, I'm doing an attribute remover, and I'm just removing data source. Whereas alternatively, I could, click through all these to keep them and just not include data source. So it's kind of the same piece of functionality. It's kind of really a balancing act between the number of attributes you want to keep or remove in terms of which attribute might be better suited from a user experience standpoint. And now the second point, or a second tip, if you will, revolves around the attribute keeper and that bulk mode that I suggested or touched on. So you'll see this little setting down here where it's create bulk features. Now, when that's toggled on, it essentially allows FME to create bulk features. So it's mainly used with like stream processing where you want to improve your performance downstream. So I've got two attribute keepers here, one toggled with the bulk features on, and then the second one with it toggled off. Now, just for the purpose of this demo, I'm using a decelerator, and that's primarily because the CSV reader will create bulk features by default, and the decelerator will just split those up. So if I were to run this again up to the decelerator, you would see that the feature counts would increase individually rather than by a bulk or like a group of, let's say 100,000. So if I run this again, I'm just going to run to these. You're going to see the feature counts will differ between in terms of how they jump out. So this top one will split out the groups in 100,000, whereas this bottom one, you'll see them increase it by potentially as low as like 1,000 or so. They'll give you very sporadic feature counts. So while you might not necessarily see a performance increase here, it would be downstream of any further processes or transformers is where you would really see the performance gain. So you'll see that. So we're chunking them out in 100,000 here. So I'm just going to stop this and I'll just run the bottom part now so you can see the difference. So there you can see the difference right out the gate. So we're just sending them out in as they're received essentially rather than in big batches. So yeah, again, just to recap, the attribute remover and keeper are an easy way to keep or remove attributes, including lists. And remember, sometimes the opposite transformer is what you want in terms of a better just user experience. And then the easiest way to create bulk features can be done with the attribute keeper to improve any downstream performance. I will now pass it over to Chris.
All right. Thank you, Trent. And I think this is a good place where we can do a little bit of a reminder. If you haven't already, get your questions in that questions panel. Also, feel free to chat us out with anything else that isn't necessarily a question. We're going to be happy to review these and hopefully answer them as much as possible during the live session. And if we can't get to them then, we will definitely respond at the end. So we'll be talking about the attribute manager for the next section here. So the attribute manager is really that one transformer to rule them all. You can do all things attribute related here. So if you're adding new attributes, renaming existing attributes, copying and pasting attributes, deleting, reordering, you name it, you can do it all in this one transformer. It also has a ton of built-in functions, and this isn't necessarily exclusive to the attribute manager, but it gives you a lot of flexibility within a single transformer. So this would all be done in the text editor or the arithmetic editor. So you have a number of built-in functions, and we'll hop into Workbench in just a little bit here to see what the difference between the FME feature, string, math, and date functions are. There's also another capability for conditional values. So essentially you can build a tester into an attribute manager, test for certain conditions, and if that condition is met, set a value. If it isn't met, then you can set a different value. So a lot of great things there. You can also do importing and exposing attributes. So this would be using the dropdown on the right-hand side there. Again, we'll see this in the demo in just a minute here. But this gives you the ability to import a schema from an existing data set or import unexposed attributes from the canvas. So that could be used with feature caching. Super handy to do if you're working with anything from an API or JSON attributes. Oftentimes they're not exposed by default, so you can expose them nice and neatly in the attribute manager. And the last little bit to mention here is the adjacent feature handling. This is definitely more of an advanced feature, and you don't necessarily need to use this for most workflows. But if you're looking for previous values or values in neighboring features, you can do that with the adjacent feature handling. So you can allow the attribute manager to look, say, 5 features ahead and behind and check for values and set values based on that. So at this point, we'll hop into Workbench. I'm just going to share my screen here. Okay, so yeah, we're looking at a canvas full of random transformers rather. Most of them are either string attribute or coordinate related. So here you can see a number of 29 different transformers that are essentially built into FME functions and string and date functions in the attribute manager. So in a sense, you can replace almost all of these transformers using the built-in functions in that attribute manager. You can also do importing and exposing attributes. So this would be using the dropdown on the right-hand side there. Again, we'll see this in the demo in just a minute here. But this gives you the ability to import a schema from an existing data set or import unexposed attributes from the canvas. So that could be used with feature caching. Super handy to do if you're working with anything from an API or JSON attributes. Oftentimes they're not exposed by default, so you can expose them nice and neatly in the attribute manager. And the last little bit to mention here is the adjacent feature handling. This is definitely more of an advanced feature, and you don't necessarily need to use this for most workflows. But if you're looking for previous values or values in neighboring features, you can do that with the adjacent feature handling. So you can allow the attribute manager to look, say, 5 features ahead and behind and check for values and set values based on that. So at this point, we'll hop into Workbench. I'm just going to share my screen here. Okay, so yeah, we're looking at a canvas full of random transformers rather. Most of them are either string attribute or coordinate related. So here you can see a number of 29 different transformers that are essentially built into FME functions and string and date functions in the attribute manager. So in a sense, you can replace almost all of these transformers using the built-in functions in that attribute manager. You can also do some very basic geometry calculations as well. So if you're doing area calculation, getting dimensions, checking for the length of vertexes, how many parts are part of an aggregate, or just finding out what the coordinate system is, you can do all of these things in the attribute manager, which is pretty great. So I'll scroll down here to just the attribute manager, and we'll open it up in the text editor in the parameters here. You can see that you can obviously do some very basic things like renaming. So you just have to click on it and change the name. You can set default values. You could say, don't do anything, just keep it as it is. You can remove them and reorder as well using the arrows on the bottom left-hand side. So this is the 2023 version of the attribute manager. So if you're savvy enough and you haven't noticed it before, there's actually going to be a date type as well. So you can change from varchar to buffer, JSON, binary, datetime, and a lot of other data types in there now. So that's new functionality coming to 2023. So watch out for that because it could be helpful in your workflows. I'll hop into, just by clicking on the value, we'll focus on the values at this point. I'll click on the 3 dots, and this is going to open up a text editor. And this is where you're going to see all of the features and functions available to you. So in a text editor, you get access to, let's collapse those, the FME feature functions. So this would be the basic geometry functions. You get string functions if you want to do any string searching, change the case, do padding or anything like that. You get math functions if you want to do any arithmetic. We'll see an arithmetic editor in just a minute here as well as datetime functions. So you have the full arsenal of tools built right into the attribute manager here. And that's kind of why it allows you to replace those 29 transformers. We also have conditional values. So again, if you just click on the drop-down menu instead of that 3 buttons, you'll see there's a conditional values here. In a sense, it builds a tester directly into that. So you can kind of set those if-else conditions. So if an attribute is numeric, let's do some arithmetic on it. So in this case, we'll see that there's the arithmetic editor, and we can do some basic math here. You'll notice that the functions are slightly different because they're only math oriented in this case, but they're still all available to you. And lastly, you also have the ability to do some string concatenation as well. So you can enter in some attributes, do some hard-coded values, and then enter in additional values. And this would be great for creating things like labels or HTML content as well. So a lot of great stuff in here, as well with that import from feature cache. So if you have any unexposed attributes, you can do so here or import from an existing data set. So that is essentially building in all of that functionality. Looking at that specific attribute manager is replacing these 7 transformers. So kind of simplifies the workspace a little bit, but as you can see, you could do a bookmark and collapse it to essentially accomplish that same thing if you just want to simplify the look of the workspace. This isn't to say that you need to replace all of these functions in an attribute manager. If you prefer to use the transformers, definitely do so. And you can also clean up your workspace simply by putting them in a bookmark and collapsing. So a lot of great options. And yeah, as Trent was mentioning, there's often a couple of different ways you can do the same thing in FME. So There's not necessarily one perfect way to do it, but you have the options with a flexible transformer like the Attribute Manager. So that wraps up here. Go back to the slides, and we'll pass it off to Jovita.
Thanks, Chris. Next up is the attribute filter. So the attribute filter is a really neat transformer, and sometimes it can be a little bit difficult to figure out when to use it. So we'll talk about when we'd like to use it first before we really go into what it looks like. The attribute filter can commonly be confused with when to use the tester or the test filter. And there is no real right answer, but there are certain guidelines that might help you decide which one to use. So when would you want to use it? Well, you might want to use it when you have limited unique string values. The reason why I word it that way for limited unique string values is because it's very similar to the FeatureReader if you decide to read it as the output ports to have one per feature type. So let's say if you had 30 different string values that you wanted to make output ports out of, your attribute filter would get really long and it wouldn't be very useful anymore because you wouldn't be able to read everything. Another reason you might want to use it is to group data for specific processes. Let's say you send email campaigns, and on Monday, Tuesday, and Wednesday, you want to use one specific template, whereas Thursday, Friday, and Saturday, and I hope you don't send that many emails, but you might want to use a different template or process. Another reason is to identify features that don't fit. So in that screenshot there, you can see some features being filtered through the missing port or the unfiltered port, and you might want to do something different with that information to either assign more information to it or process it differently. When might you not want to use the attribute filter? As we mentioned, string values, if you're using numeric data, you might not want to use the attribute filter because you don't want to port for like 1, 1.25, 1.3, 1.4. You'll want to use the tester or the test filter. If you're outputting specific feature types, let's say you're going from reader to writer and you just want to keep the same schema, don't use the attribute filter. Just use the feature type fan out, and that will keep it a lot simpler. With that, we'll head into our demo. So here we have a workspace with 3 different readers already. And right now we've got our KML selected. And these are just areas or neighborhoods in the city of Vancouver, or a part of the city of Vancouver. Below that, we've got our DWG. So the first one was KML. We've got our DWG of road types in a similar area. What this workspace currently already does is it takes the lines of the road types from the DWG, takes the information about what neighborhood it's in. So now we can add an attribute filter. And fun fact, you can type any part of it to pull it up. We'll connect the line. And we want to filter by neighborhood name. As you can see, I've already run most of this workspace. So what I can do, and what you probably recognize from the Attribute Manager, is this beautiful import button, and importing from feature cache. We're going to grab our neighborhood name, and it gives me downtown, Fairview, Kitsilano. You might recognize a few of these. We'll import it and press OK. As you can see, it populates under the unfiltered, so we've got new ports for each unique string value. Once we run it, we can see that we've got a couple of missing values. So maybe that's something that I want to assign. And you can see that that's just slightly out of the scope of our neighborhood data. So we've got stuff in Stanley Park and between on the water. If I wanted to use this exact same schema for another data set, and these are points in Vancouver from Excel of public art, I could just duplicate this and that wouldn't be hard, but then I wouldn't be able to show you the import from data set. So let's do that. So we want, once again, the neighborhoods, and this time we're importing from data set. We're going to use that same KML we had up here. Okay, next, we want our neighborhoods and our neighborhood name. So we've got that same information again, downtown, Fairview, Kitsilano, etc. Import it, and we'll press run. Let's scoot this down. So now we can see we've got data that fits mostly the schema, but we do have some data that's unfiltered due to a blank sheet name. Excuse me, just moving my dialogues around. And we've got 13 that are missing. So neighborhoods don't have that information. So maybe that's something that where I would want to assign the information or process it differently. With that, we will head back into the slides and pass it along to Nampreet for the feature merger.
Thanks, Javita. Yeah, so I'm going to be talking to you about the feature merger and the one atypical usage of the feature merger as my tip for the transformer on how to combine attributes from two data streams without using a common attribute key. Before I get into that, for those of you who aren't familiar with the feature merger, it's one of many transformers that can be used in FME to merge attributes and geometries from multiple data sets together. This is often done by using a common attribute key that exists in both data sets to join on. Why is joining and merging so important? The ability to combine multiple data sources is basically the backbone of data integration, and FME is all about data integration. So as I just mentioned, we often use a common attribute value between two data sets to merge tables together, two data sources together. Besides using attribute values, the feature merger also allows you to use expression as join keys as well. But we don't always have to use a common key between data sets to create a join. I'll get more into this by sharing my screen and going into a demo. All right, so the first thing I'll show is a typical merge using the feature merger and using a common attribute key. We've got two tables here, one containing produce inventory with some attribute values here, another table here that has those produce items listed with their suppliers. So what we want to do is, our goal here is to create a report that shows the price of each produce along with the supplier in one table. The way we do this is using the feature merger, and our goal here is, again, to merge the supplier information from this table with that inventory table. Let me go into the feature merger and show you how we do this. We'll focus in on the join on parameter here. To join two data sets, typically you need a common key between the two data sets. So here we're using the item attribute to perform the join, and that allows us to combine the two data sets together. I'll also highlight a couple of other cool parameters here, which provide flexibility on depending on what type of join you want to perform. So if you want to, if you have multiple matches that you want to capture, you probably want to look into using the process duplicate suppliers and generate list parameters here. And our documentation goes into pretty good detail on where, when and where you should use those as well. Moving on to the one tip and trick that I want to highlight about the feature merger is how to perform a join between two data sets without a common attribute key. The reason you'd want to do this is if you are deriving a value from one data source and you want to apply that value to all the features from another data source. So here I have an example of a table containing the list of Canadian provinces, their population and area. And what I want to do is calculate the percentage population area of each of the provinces compared to that of the entire country. I've got another table here listing the population area of a few of the countries in North Central America. And so what we want to do is basically join the population value and area value of Canada with all the features or records here of the provinces so that we can calculate the percentage of area downstream. So what I've done here is just isolated that one feature containing the values for Canada, and I want to join these values to each of these features here. The way I do that, and you can see we don't have a common key between the two data sets here. So what we can do is use a little trick in the feature merger and set the requester and supplier in the join on parameter as equal. So here I've chosen to set them to the value of 1, and that's going to allow me to combine or add the population of Canada and the area of Canada to each of the provinces here, and then go on to calculate the percentage of each using these values, and then producing my final report, which has the percent area and percent population of each of the provinces. Going back to the slides here. So with the feature merger, with some of the things I've highlighted there, you can see that FME makes it easy to bring multiple data sets together. We have pretty comprehensive resources on the feature merger and other transformers that may be similar or more appropriate to perform joins in FME. So please definitely check out, I've got a webinar listed there and also a link to a documentation for the feature merger. I'll pass it on to Debbie.
Okay, thanks, Nampreet. I'll be talking about the counter today. So on the surface, the counter is a simple transformer that creates a numeric attribute with incremented values. You can specify the number to start the count from, and you can also set the attribute name of the count. However, don't let this simplicity fool you into overlooking more powerful functionality of this transformer. Once you expand the advanced section, you should be able to perform some not so simple workflows using this transformer. You see parameters such as count scope and count domain, as well as an option for group processing. Using these parameters, you can, for example, create a unique count for different values of an attribute. You can also count incrementally using the same counter at different points in the workflow. For example, you have features 1 and 2, and at a later point in the workflow, you can continue counting features at 3.
In this workspace here, I have a data set about public trees in the city of Vancouver. Each tree feature has a numeric unique identifier and other attributes such as neighborhood, location. If you want to see the number of trees in each neighborhood, you could use a statistics calculator. But it is also possible to create a basic histogram using a counter. You can do this using a counter configured with a group by on the neighborhood attribute. In order to use group by processing, the count scope must be set to local, and this will enable group by parameters. You can also use a counter to map text data to a number using the group ID parameter. By setting an attribute name in this parameter, the output should be a number for each unique neighborhood value. You can then use a sampler to get the last feature of each group, and each sampled feature should contain the total number of trees in each neighborhood. You can also see each unique neighborhood name is now a number in the neighborhood number attribute.
So moving on, Let's say the city planners planted more trees and you need to add these trees to the existing data set. However, these new trees do not have a tree ID yet. In this case, since the tree ID is a numeric attribute, you can use 2 counter transformers and 1 count domain with a global scope to continue creating a tree ID count based on the existing dataset max. So in this bookmark here, I have a sorter and sampler transformers that control the feature that reaches the counter first. This is important because the first feature determines the number to start the count from. In the first counter, the count start parameter is set to the numeric attribute that we need to generate an ID value for, the tree ID, and also with a global count scope. And then the next counter will continue the count based on the first counter transformer, since the count domain has a global scope. Remember, you need to set the same count domain name for both transformers. For the second counter, you can leave the count start parameter as the default 0, since it will use the count start value from the first counter transformer. Notice that I have added a feature holder and tester transformer before the second counter. This is to ensure the first counter transformer that initializes the count domain is run before the second counter starts working. Otherwise, your results would be incorrect, as the counter would start counting from 0. Depending on your workflow, this may not be necessary. But it is one way to ensure features reaches the subsequent counters after the first counter has been run. And there you have it. The second counter starts counting at 250,001, as the maximum in the existing data is 250,000. And that is it for my demo. Let's go back to the slides. Okay, so some tips. Be careful using a global counter with partial runs when feature caching is enabled. If you're familiar with the variable setter and variable retriever, the count domain behaves similarly. You want to make sure the first counter that initializes the count domain is run for each time for a partial run. Otherwise, your results may be incorrect. In addition, feature order is important. So you would want to control which feature reaches the counter first. The first feature to reach a counter with a global scope determines the value to start the count from. I'll also note that there are some issues with version 3 and 4 of the counter where it did not work correctly with global count domains. This has since been fixed in latest versions of FME 2020.2, so try the latest version of FME if you're having any issues. And I will pass it on to Evie.
Thanks, Debbie. Yes, I will be talking about the Clipper transformer. The Clipper transformer cuts out an input feature, the candidate, to a defined feature boundary, Clipper. The inputs can be anything from points, lines, polygons, rasters, or even surfaces, solids, and point clouds. The Clipper acts like a cookie cutter where there are 2 outputs, inside and outside. So I'll show you with a little demo some insights. Okay, so this you can see here, I have a couple creators. So we saw previously creating some polygons, some lines, points, and a bounding box in the middle to clip. So this is just to show you what like the inside port would look like and the outside port. This is typical what you would use it for. So the outside port would be like an erase and the inside port would be like a clipper. So yeah, but some tips and tricks that I'd like to share with you is if you have a very large data set, some of the parameters would be different. So here I have a very large raster. I'm not going to run it because it would take too long. And you have to have in the Clipper parameters, clip original candidates. This is to revert back to a previous version of the Clipper transformer that would show you, that would have a processing of large rasters. Without it on a different, like clip only outside remainders, it would expect to store the entire data set in your memory, which may not be possible. Something that could also go around this is if you could add a tiler, I have here, in the middle between your data set and the Clipper to downsize the input here. This would make it so that your Clipper would be able to perform. Go back to the slides. So some tips and tricks. What can you clip? Anything. Remember what version of the Clipper you are using, because the parameters might have changed and performance might have been optimized for different inputs. And break down your data before inputting to save on computer processing. There are some resources here to a previous webinar and an article that might be useful. And yeah, that's it. I'll pass it on to Elizabeth.
Awesome. Thanks, Evie. So just to wrap us up here today, some next steps that you can take. If you do wish to chat with us about anything data, contact us at info@safe.com. You can also download the latest version of FME and try out these workspaces for yourself. We'll be sending those out in a follow-up email shortly here today as well. There are over 500 different transformers. This is only scratching the surface. So the full gallery can be seen at safe.com/transformers. And there's a handy little help me choose a transformer feature there on that page that you can make use of. We have lots of upcoming and on-demand webinars on safe.com/webinars. So definitely check that out and register for any that are upcoming that look relevant to you. And we also do have a community badge code for those of you who are part of the FME community. I will leave that in the chat here. And if you weren't yet a part of the FME community, definitely encourage you to visit. It is a great place to network with other FME users alike and FME experts. Register and apply to present at our Peak of Data Integration taking place in Bonn, Germany this year. I will leave a link in the chat for that as well in a moment. And with that, it does look like we have some time remaining here for some questions. So if you didn't get any questions that you might have in, please drop those in the questions tab in the next few moments. And I'll invite our presenters back on stage here and we'll take a look through now. Was there any team that we might want to start off with here?
Just taking a quick scroll through again. Looks like we got to most of them from earlier on in the webinar, so that's good.
Yeah, awesome. Yeah, thanks everyone who left questions. Some really awesome thoughts and comments there this morning. And it was cool to see too users leaving their own tips and tricks in the chat panel, I noticed too. So thank you everyone. We'd love to see those as well. Right. Any others that we might want to chat to more, team, or does it look like we've got them pretty well covered?
I think we've got most of them. The only one we haven't quite answered yet is the recommendation for a transformer to withhold or postpone some features from streaming while using transformer elements. For the first option, say area or supplier in feature caching mode. The first one that comes to mind for me would be either a feature holder, which would allow all of the features to arrive at that feature holder transformer before it gets released and then passed downstream. So that would be probably my first suggestion for that one. The other one would be potentially a decelerator. So it does a similar operation where you can specify an interval to hold the features for before they're released by that transformer for downstream processing. So either the feature holder or the decelerator would probably be my suggestion. It'd be interesting to see what the use case is for that, but I'm not sure if anyone else has any thoughts on that, but those would be probably my first two recommendations for transformers, starting with the feature holder and then the decelerator if you have kind of a time interval that you're having in mind.
Awesome. All right, and it looks like we do have a new question that's come in regarding the clipper. So I'll bring that on the screen here.
Yeah, I can probably try to answer that. And the answer is yes, you can clip a mix of raster and vector features. You can, if you have multiple features to clip, you just put them in the same input port and it should clip them all to what you want to clip. I don't know if that answers your question.
Perfect. All right, last call to the team. Is there any others that we want to address further in the panel there? Or are we all good to wrap up at this point?
I think that is all of them.
Awesome. Well, thank you so much to our whole team of presenters here this morning and to our audience. Thanks for joining us here today. I did just leave a link in the chat for our webinar survey. So if you can leave any feedback, we really appreciate it. It's just a few multiple choice questions. And with that, thanks everyone and hope you have a great rest of your day. Bye for now.